In number 22, we're going to be graphing this rational function. So we'll start by finding x-intercepts. So the x-intercepts occur when the numerator is 0. So that would be x equal minus 2. So that's our x-intercept. Okay, now for the y-intercept, we just replace x with 0. So we have y is equal to 0 plus 2 on top, where that's 2 over 5. And times minus 1. So the y-intercept is minus 2/5. And there's our x-intercept. Okay, vertical asymptotes. Vertical asymptotes occur when the denominator is 0. So that would be x equal minus 5. And x equal 1. Okay, those are the vertical asymptotes. And now the end behavior. The end behavior is also where we determine if we have a horizontal asymptote. Okay, so for the end behavior, we write y is equal to, just look at the leading term in the numerator and the leading term in the denominator. If we were to multiply this out, we would have x squared plus lower terms. Okay, so that's going to behave like x over x squared, or 1 over x. That's reduced. So for large x values, f of x is going to behave like 1 over x. So that's what we look like. We look at 1 over x when determining the end behavior. So let's do that now. As x goes to infinity, y behaves like 1 over x, which will go to 1 over infinity, or 0. Y goes to 0. And then as x goes to minus infinity, 1 over a negative number that's very large in absolute value is also close to 0. So that also goes to 0. Y goes to 0 as well. Okay, so on the right and on the left, the curve levels out towards the x-axis. So that's the horizontal asymptote. So let's write that y equals 0, or the x-axis, is a horizontal asymptote. All right, now we're going to do a plus-minus analysis and graph at the same time. Okay, so let's do that. So we'll start by putting the intercepts and the vertical asymptotes on the graph. So, well, we only have one intercept. That was at minus 2. That's one x-intercept at x equal minus 2. So we'll put that there. Okay, and then we had 2 vertical asymptotes at minus 5. Let's put an open circle there. And dotted line at minus 5. And at 1. Open circle at 1, and vertical asymptote at dotted line, vertical dotted line. Okay, let's just put in the y-intercept, which is about here. That's minus 2/5. Y equal minus 2/5. Okay, now let's do the plus-minus analysis. So we're looking at, let me just write down the function. Let me copy it down over here. x plus 2 over x plus 5 x minus 1. Okay. All right, now we're ready for the plus minus analysis. So to the right of 1, if we put in something like, substitute in something like 2, well, 2 plus 2, that's positive. This is positive, 2 plus 5, and 2 minus 1, everything's positive. So I'm going to just write down positive to the right of 1. And now in between 1 and minus 2, we can substitute in a 0, for example. If we do that, we have positive on top, positive on the bottom, times negative. 0 minus 1 is negative, so that's 1 negative. All right, so between minus 2 and 1, the function is negative, below the axis. All right, now between minus 2 and minus 5, let's substitute in minus 3, for example. And here we get something negative. Here we get something positive, and here negative. So that's 2 negatives. So that would be positive. The function would be positive between minus 5 and minus 2. And now let's say we substitute in minus 6, and we have something negative here, negative here, negative here. That's 3 negatives. 3 negatives, so the function is negative to the left of minus 5. All right, let's see what's happening at the asymptotes. So let's say starting here on the left, because the function is negative here, that means to the left it's going down to the left of this vertical asymptote. Now on the right of the vertical asymptote, the function is positive, so that would be going up to infinity. All right, now let's look at this asymptote, and to the left it's negative, that would be going down, and to the right it's positive, that's going up. Okay, now here minus 2 is a crossing point. The graph is going from positive to negative, so it's crossing over like this. All right, now what about y equals 0, the x-axis? That's an asymptote, the horizontal asymptote. So the function is leveling off here, and now because it's positive, I'm going to draw the leveling off above the x-axis because it's positive. And here I'm going to draw the leveling off at the x-axis, or at y equals 0, below, because it's negative. Well, now we put in all the essential information, so we just connect the pieces. So there we go, connect those two pieces. And here we're going to connect, we're going to cross, go through, 2 minus 5 and down. Okay. And here we're just going to swing around and connect these two pieces. And that's it. That's our approximate graph. In number 23, we have a few inequalities. The first one is a quadratic inequality, and we start by setting the right-hand side equal to 0, and then we do a plus-minus analysis. Okay, so let's do that. Subtract 2x from both sides. Okay, now the right-hand side's equal to 0. Before we do the plus-minus analysis, we have to factor. Okay, so we'll just pull out an x here. So we have x times x minus 2 less than or equal to 0. All right, plus-minus analysis of x times x minus 2. Let's do that now. Basically, we want to see where is it positive and where is it negative. So we draw a number line, and we put the zeros of this expression on the number line. That would be x equals 0 and x equal 2. And now we check in between the zeros to see if this expression is positive or negative. So let's say if we substitute in a 3, for example, something to the right of 2, into this expression, we have 3 times 3 minus 2. Both are positive. Okay, so that 3 times 3 minus 2 is positive, so I'm going to write positive here. Now between 0 and 2 we have the number 1. We can substitute that in. 1 times 1 minus 2, that's positive times a negative, so that would be negative. And to the left of 0, let's say we substitute in minus 1, and this is negative and this is negative. The product of two negatives is positive. All right, now we want to see where this expression is less than or equal to 0. That means negative or 0. So let me just shade in the negative portion of the number line. So this expression is negative between 0 and 2, and it's equal to 0 at 0 and at 2. So we would have the interval from 0 to 2 with square brackets. So we're including 0 and we're including 2. If this were just less than 0, then I would put round brackets here. Okay, let's go on to the next inequality. This time we have a rational expression, numerator and denominator, and we're going to do a plus-minus analysis again. So here we have 0 on the right-hand side, but not everything is factored. Let's just factor the denominator. The denominator factors into x plus 5 times x plus 1. All right, so we'll do a plus-minus analysis on this expression. So let me write this expression next to the number line. Getting ready for our plus-minus analysis. Okay, on the number line we're going to put a minus 1, a minus 5, the zeros of the denominator, and 7, the 1 0 of the numerator. So I'm going to put minus 5. Of course, we do this in order. Open circle, because that's a 0 of the denominator. And minus 1, again, open circle. Both minus 5 and minus 1 are not in the domain of this expression. And then 7 gets a closed circle. All right, because we can substitute in x equals 7. And now we'll look in between the zeros of the numerator and denominator. So let's say we substitute in 8 into the expression, then everything will be positive. And if we substitute in 0, which was between minus 1 and 7, the top is negative and the bottom two factors will be positive, so that's the entire expression will be negative. And let's say we substitute in minus 2, which is between minus 1 and minus 5, then this is negative, positive, negative, so two negatives, so the expression is positive. And if we substitute in minus 6, then this is negative, 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 3 negatives, so the expression is negative. Now we want to know where is this less than or equal to 0. That's negative and 0. So let me just shade in the negative portions of the number line. And what about the equal 0 part? Well, only at 7 is this expression is equal to 0 when x equals 7. Not at minus 5 or not at minus 1. That's where the denominator is 0. All right, so let's write down the intervals for which this expression is less than or equal to 0. So that would be first for this part here. That's from minus infinity to minus 5, open brackets. And then we have from minus 1, open bracket, to 7, close bracket. Okay, and I can put a union symbol in between. Okay, and finally we have one more inequality. Again, we want 0 on the right-hand side. So first we'll start by subtracting 1 from both sides. Okay, that's minus 1 less than 0. And now we want to get a single fraction on the left-hand side before we do our plus-minus analysis. So we're going to add these two terms. We're going to get a common denominator. So we'll write 1 with the denominator x minus 1 and the numerator x minus 1. And now combine. So we have 2x plus 1, and we're subtracting x, minus x, and then we're subtracting minus 1, minus 1, so that's plus 1. Okay, let's just simplify the numerator. We have 2x minus x, so that's x. Then 1 plus 1, x plus 2. So we have x plus 2 over x minus 1 less than 0. Okay, we'll do a plus minus analysis on this expression. All right, so we have x plus 2 over x minus 1. Put the zeros of the numerator and denominator on the number line. So first minus 2 with a closed dot, because that's coming from the numerator. And 1 with an open dot, because that's coming from the denominator. And then we substitute in something bigger than 1, like 2, and we get positive top and bottom. And in between minus 2 and 1, let's say we have 0, and that would be positive, negative, so that's negative. And let's say we substitute in minus 3, that would be negative, negative, so the quotient is positive. And now we want to know where this is less than 0, so that would be right here, negative. So it's less than 0 between minus 2 and 1. Open brackets. We're not including the 0 at minus 2 because this is strictly less than 0, not less than or equal to 0. Okay, so there, that's it. Okay, number 24, we want to find the value of an investment of $1,000 held at 6% for 10 years. So first we write down our basic formula here. Okay, so here we have y equal p, standing for the principal, that's the $1,000, e to the RT. Let me add here compounded continuously. Okay, so using this basic formula, we have y is equal to 1,000, e to the r, that's 6% written in decimal, that's 0.06, and the number of years that the investment is held, that's 10 years. That's just 0.06, 10 years. Okay, so we need our calculator to evaluate this. This is 1,000, e to the 0.06 times 10, that's e to the 0.6. Okay, so let's do e to the 0.6 on our calculator. And I have 1.822. Okay, and now just multiply 1,000 times 1.822, and we get $1,822.